Hello, welcome back. Today let's try to solve another Leetcode problem. 1162, as far from land as possible. Let's first understand the problem, and then I'm gonna first explain my method, and then finish my coding by using the method. And while my coding, I will explain each line of my code. Now let's check the problem. So we are given an n times n matrix. So this is a grid, and inside the grid containing only values of 0 and 1. So 0 represents water, and 1 represents land. So these ones are the land, and zeros are the water. What we need to do? We need to find a water cell such that its distance to the nearest land cell is maximized. It means we're gonna find some zero cell because zero is water to find the nearest land to maximize. So for example, this is water, its nearest land is 1 because this problem, it is very clear. We are told it is Manhattan distance. It didn't like Leetcode problem 542 01 matrix. They just told us some neighbors, but this is a really good problem because it's really clear. It told us it's Manhattan distance, and we know that for this 0, the distance, as you can see, it is 1. But for this 0, the minimum distance, for example, to this land, and this land, and this land, it is 4. But what is the minimized? The minimized, is still 2. What about the maximized? It is 2. So that is why we're gonna return 2. We just need to understand a little bit about the problem because, we need to find a water cell such that distance to the nearest land cell is maximized because there is a nearest and there is also maximized. We need to understand because for this one, the nearest is here and it's maximized, and for this one, it's also 2. So the final result is the always be the nearest. So 2, 2, and 2, 2. So the final result is 4. But for this one, for here it is 1, and for here the nearest is 1. But when this is 0 to this one, so what is the nearest? Because for this 0, this is the water. Its nearest is still 1, 1, 1, 1. Always be 1. So it means the final result is 1. But we need to return the maximized. So it is 2. I think it is clear. For example, let's check this one. So let's check so this is the 0 is water to the land. So if this is our result, water, so the value is just 1. It's not maximized. But for this water, let's check. So to the land, but there's only one land. So we just check this land. What is the distance? 1, 2, 3, and 4. So the final result is the maximized is 4. It means there may be some other land, but for this example 2, there's only one land. But we can understand this may be easier. Because for this water, to find the land, the nearest is 2. It means the maximum. It means the minimized of all those distance. Even minimized. So the final distance is still 2. So for this problem, it's exactly like the Leetcode problem 542 01 matrix. It is called multi-source BFS. What we should do, we should first find the multi-source. It means we need to find many sources. So the sources is 1. Because we're gonna find the water to the land. So why not? We just first find the land, all the land, and then we're gonna use this land to find the water. If we can find the maximum distance of the water using the multi-source BFS, so this means it's the maximized distance. I'm not sure if you can understand Yeah, you need to, because we need to find the nearest land cell is maximized. So it means we need to use this land. This is a land and land and land here. Just use BFS. This is the multi-source, and then use BFS of this land to find the nearest, to find the furthest water. So here it's not the furthest until we find this one, the furthest, and then we're gonna check the distance. So this distance means it's the nearest distance to all those lands, and it is maximized. Yeah, so this is something we need to understand. If we understand that, it should be really easy to do, just using the multi-source BFS template to finish the problem. Now we just need to put the land inside the queue and visited set, and then using BFS. So the type complexity is still m times n. So yeah, the m n is a grid, it's a square. So the length is just 100. 100 times 100, it is 10,000. So it means we can pass for this kind of a method. Now let's just do it. Let me write the template for the question first. So I'm gonna use R and C as my row and column. So it should be less grid and less of grid 0. And then I'm going to use a queue and visited set. So the queue should be the queue and visited would be a set. After that, I'm going to use directions as my BFS search. I'm going to search for directions. So the directions inside, it should always be, we don't need to take care of up, down, or left or right. We just need to prepare those values for those 4 directions. So this one should be 0, -1, and inside it should be 1, 0, and -1, 0. For this one, I mean, if we are familiar with it, we don't need to understand. Even maybe, you think this one is this is the 0. It means the row we didn't change, but for the column it is a +1. It means at the right side. But we don't need to understand that. We just need to use our template because it's just for tuple with numbers, means 4 directions. We don't need to take care of this is top or down because the sequence doesn't matter. Now let's just finish the first part. Prepare the multi-source and put that inside our queue. And we just need to use a for loop for R in range, capital R, and for C in range, capital C. Now we're gonna put it inside our queue. So queue dot append, and inside it should be R and C tuple, and visited dot add, also with a tuple R and C. Now let's put it like this, and I will correct it later if it is not okay. But normally for the template, I should write my code like this, and then I'm going to use BFS. So it will be exactly the same, just use a BFS to check the queue, and RC should be queue dot pop left. After popping it out, we need to check the DR and DC inside the directions. Now we're gonna update the new row and new column. It should be updated like this. So the R plus DR and C plus DC. After that, we're gonna check if this row is more than and equal to 0 and less than R, and column more than and equal to 0 and less than C. And we need also check this row and column not in visited. This means If they are not invisited, we're gonna put it inside the queue. So queue dot append this tuple, new row and new column, and visited dot add the new row and new column. Now we're gonna check our result. So we need to return a number. So it means we're gonna prepare a result from here. So the result would be equal to -1, because there are some cases if we didn't find, it said if no land or water exists in the grid, we're gonna return a -1. Yeah, so this means if no land, always be water, always be 0. Where can we find the land? Because there's even no land, because inside the queue there's nothing. So we're gonna return a -1. Yeah, if there are always zeros or always ones, we're gonna just because if there are always ones, we cannot even find the water, because always be land. There's no water. How can we find the distance? Yeah, it's gonna be -1. This means inside our queue always be ones. But when we pop it out, we're gonna check, but we cannot find anything. So we're gonna return this result. So this is finally we're gonna return the result. But before that, what should we do? We should update the grid. Yeah, and now let me update the grid. So what is the grid? The grid row and column as before. If you did the questions for, if you saw my videos for Leetcode 542.01 matrix, we should equal to, so the grid column and row and column should be the grid. Where are we coming from? We are coming from this R and C, so it should be R and C should plus 1. Why we need to plus 1? For example, because if this distance is 1, so for here, if we are using BFS to track this XY grid XY to check this point, so it's gonna plus 1. Yeah, but from the first one, is this right? Because here is 1 plus 1, it means 2. It means it is not right. Yeah, so what should we do? We should first set our multi-source to zeros. So this would be exactly the same as Leetcode 542.01 matrix. If we set it to 0, it means here will be updated to 1, and here will be updated to 2, and our final result should be, let me put the final result should be max result with grid, row, and column. But how should we put this to 0? Yeah, it's easy, because here we just gonna loop through the R and C, we put it inside. Why not at the same time we just update the grid R and C equal to 0? Yeah, you may think this is not right. Why I need to update? If I update it to 0, maybe it is wrong. How can I use BFS? It doesn't matter, because we use the visited set and the queue for the BFS. We didn't use any values inside the BFS. That is why it doesn't matter if we update the grid RC to zeros. Even it is zeros, because we never check the values. We always check if this RC as a tuple inside a visited set or not. We always check if this row and column inside our range or not. Yeah, because that really doesn't matter. We can update it directly from here. Now let me run it to check if there are any mistakes, because there are a lot of code. Yeah, it seems something wrong. So here output is -1, but expected 2. Let me check it. Yeah, because here I didn't check. So I needed to put the ones inside. Yeah, because I didn't take the ones. I put everything inside. Of course, it is wrong. Yeah, so I needed to check if the grid RC equals to 1, because I only need to put the land inside. Now I'm going to put these values inside and check. Now let me run it to check if it really works. It's not grid is not defined. Let me, yeah, in line 20 here, the grid should be grid. It's a typo. Now let me check again. Yeah, now it seems okay. Now let me submit it before analyze the time complexity again. Yeah, as you can see, it really works. It's 78% of all Python 3 submissions, and it's really fast. Now let's analyze the time complexity before the end of the video. So for the time complexity, we just need to check this queue, because everything is dependent on queue. And how many tuples inside the queue? It is m times n. So m times n, it is 100 times 100. It is just 10,000. So it means it's not a big value for Leetcode. Yeah, it is just n square for the time complexity. Thank you for watching. If you think this is helpful, please like and subscribe. I will upload more Leetcode problems like this.